Hi, my name is Jos Deschagt and I am the Operations Manager at Engilico. And I'm very happy to introduce to you today our newest product Hyperscope for 100% seal inspection on rigid plastic packaging like trays, thermoform and pots. We will now switch to a PowerPoint presentation for more in-depth information about this exciting new technology. If at the end you have any questions, please contact us on info@engilico.com. I hope to talk to you soon. Bye-bye.
Welcome to this presentation, where Angelico will introduce its latest product, Hyperscope, for seal inspection on rigid plastic packaging based on hyperspectral imaging. In a nutshell, Angelico is a Belgium-based technology company founded in 2011. We have an enthusiastic team of 18 people with offices in Belgium, Germany and the USA. We are expert in inline seal inspection and help our customers to obtain better packaging quality, reduce packaging costs and increase packaging productivity. Our solution for flexible packages, called SealScope, is designed for 100% inline seal inspection and monitoring of flexible packages like pouches, pillow bags and float bags. We currently have over 175 installations worldwide, mainly in food and pet care industry. Our newest solution and topic of this presentation is Hyperscope, for seal inspection on rigid plastic containers such as trays, pots and other thermoformed packages. The incentive to develop a seal inspection solution for rigid containers came from our customers. Next to flexible packaging like float pack, pillow bags and pouches, a lot of our customers also produce in trays, pots and thermoform packs, and they experience similar sealing challenges as with their flexible packages. Additionally, the use of rigid containers is very widespread, and in certain countries it is even more used than flexible packaging. So what are common sealing problems? This image shows a typical example of a thermoform package used in the food industry. It contains fresh ham packaged under modified atmosphere. As you can clearly see, it has a sealing defect, which led to an open seal, which in turn led to spoiling of the product. The main root cause for open packages is product or other contamination in the sealing area. If such packages slip through quality control, this leads to reduced shelf life, food safety problems, customer complaints, return or callback actions, and brand damage. In any case, this is always resulting in very high costs. So inline seal inspection is very important, but this has its challenges. As today many food producers use printed films for attractive looking packaging, this makes it harder to see if there is a contamination in the sealing area. Also, in the case of transparent films, there may be too little contrast between the contamination and the film. For example, in the case of water or fat. And the high production speeds don't make it any easier. These challenges are hard to tackle with standard quality control methods like manual inspection or industrial vision cameras. And when considering X-ray for seal inspection, there's often not enough difference in the density between the contaminant and the packaging material. So there is a clear need for an automated, non-destructive, fast and inline inspection solution for application with printed films and/or applications with low contrast inclusions. Hyperspectral cameras can tackle these challenges. Unlike standard vision cameras that only capture information from the visible spectrum, hyperspectral cameras record images in a much larger bandwidth in the visible and near-infrared domain. Each material absorbs and reflects a certain amount of light in function of the composition and wavelength. Hyperspectral cameras can measure the reflected light and make a spectral profile. The longer wavelengths penetrate plastic films, and so if there is a contamination in the sealing area, it will absorb more light than in case of a perfect seal where no contamination is present. This makes it possible to distinguish inclusions when using printed film and in low contrast situations. This spectral profile, for example, allows to clearly identify fat and water in the seal. The solution we present today is called Hyperscope, a hyperspectral camera-based system for seal inspection on rigid plastic packages. The main advantage of hyperspectral imaging is that it can differentiate materials with a much higher contrast compared to standard vision cameras, and that it can also see through printed films, what standard cameras can't do, thanks to the longer wavelengths of the near-infrared spectrum. Hyperscope is an inline system that is able to inspect up to 160 packs per minute, and it can easily be retrofitted to your line. So let's see how the system is built up. The Hyperscope inspection system is positioned over the conveyor belt. The system consists of the hyperspectral camera, dedicated lighting, a multifunction operation panel, and the controller with analysis software. The system is fully made of stainless steel and washdown proof in order to operate in food production environments. If a package with contamination is detected, it can be rejected by an optional rejection unit. We will now see a demonstration video of Hyperscope in action.
This demonstration of the Hyperscope system shows the seal inspection of trays with sliced cheese. Some of the packages have a contamination such as a small part of cheese between the seal. Because the film is printed, the contamination is hardly visible by human eye or camera. Each package is checked by the hyperspectral camera up to 160 packs per minute. The results are instantly displayed on the embedded touchscreen. The trays may have different orientations on the conveyor belt, but the Hyperscope software automatically identifies the sealing area, which is displayed in green. The contaminations are detected with high contrast and shown in a different color. The system keeps track on the number of good and defective packages. When a defective package is detected, a signal is sent to an ejector that removes bad packages from the line.
We will now examine the example of the video in more detail and explain the various steps how Hyperscope detects contaminations. First, we show again the front and back of the tray with pieces of cheese in the sealing area. The first step of the image processing is to recognize the position of the package on the conveyor belt, as the orientation of the trays can slightly differ. Secondly, as we only want to inspect the seal, this area is extracted for analysis on contamination. Thirdly, we make a classification per pixel if it contains contamination or not. And finally, we need to decide whether or not to reject the package. Typically, you want to reject the package in case the contamination exceeds a certain size and/or when it spans most of the width of the seal. In the picture, we see three different contaminations that need to be interpreted. The large contamination on the bottom is considered too large and the pack is rejected. The other contaminations are too small. The criterion on rejection or acceptance of a pack can be set by the customer. Next to printed film applications, Hyperscope can also visualize contaminations with low contrast. In this example of a guacamole container, there is no visible inclusion in the seal, but you can clearly see that an air leak has spoiled the content. With Hyperscope, the contamination that allowed air to enter the package becomes visible. So in conclusion, Hyperscope is a great solution for non-destructive inline 100% seal inspection of rigid plastic packaging, allowing you to detect contaminations through printed film, and allowing you to detect contaminations with low contrasts that typically are invisible for regular vision cameras. The benefits are clear. It improves the outgoing package quality, it enables you to do end-of-line automation, it eliminates manual inspection, and reduces product returns and scrap. This brings us to the end of our presentation. If you have any questions, please let us know. Thank you for your attention.